Besides the trapezoid rule, another very common way of finding integrals by hand is to use Simpsons Rule. Simpsons Rule is, again, we're trying to evaluate an integral, and so we do the same kind of deal. You take your area that you're looking at, you're going to divide it up into n rectangles. Simpsons Rule does have a requirement that n rectangles, that n must be even. Has to be an even number in there. It's a requirement in there that you have to choose an even number. You can do 2 rectangles or 4 rectangles or 12 rectangles, but you can't do 17 rectangles. You want to do an even number of rectangles in there. And the process is, instead of now doing a trapezoid or a other rectangle or square sort of thing, what you're doing is you're taking 3 points and you're fitting you're actually fitting a parabola to the top, so that you're not just traveling in a straight line, you're hopefully getting some kind of curve in there that's matching the curve of the function that you're trying to integrate. And so you're doing a parabola fit, and the way that Simpson's method works, again, we still have delta x as b minus a divided by n, and what I want to look at for Simpson's rule, I end up doing 1/3 of f of x0 plus 2 times f of x1 plus 4 times f of x2 plus 2 times f of x3 plus 4 times f of x4 plus 2 times f of x5 plus f of x6, or however many terms that you're going to do in there. So this is using 6 n equals 6 here. But you're going to alternate back and forth 2, 4, 2, 4, 2, 4. The very first term you use once, the very last term you use once, and you alternate back and forth 2, 4, 2, 4, 2, 4. And you should always end with a 2 f of x n minus 1, and then plus f of x n there when you're done. So if I do the integral from 0 to 3 of x squared plus 1 dx, using 6 rectangles, let's do 6 rectangles again, my delta x would be 3 minus 0 divided by 6, or 1/2. And what I want to do is I want to do the same sort of evaluation of my function. I need to evaluate it at 0, and then 0.5, and then 1, and 1.5, 2, 2.5, 3. Evaluated each of those points, and you should get something like this when you do that. And then I think that one's 10, if I remember correctly. Those should be the same values that I used on the other video that we just did. Use the same values, but now we're going to do 1/3 times delta x times 1/2. Oops, I forgot that in my formula up here. You need 1/3 times your delta x. I forgot to multiply by the delta x. I need a delta x up there. So 1/3 times your delta x times your first value plus 2 times the second value plus 4 times 1 plus 2 times the 2.25 plus 4 times 4 plus 2 times 7.25 plus 10. That last value there would be 10. And so let's crunch all those numbers, see what we end up with here. let me just pause the video and do that calculation. So I'm getting 1/3 times a half is 1/6 times 49.5, and that works out to be 8.25. So our estimation of the integral from 0 to 3 of x squared plus 1 using the trapezoidal rule is 8.25.